We're continuing on with 4.9 and working with square roots. Well, it's not just any square roots, it's just things like this. So what I want you to practice is understanding the rule with square roots, but as well as why the answer comes out to be x cubed. Because we've talked about like doing square roots, and we could have pull pairs in front. So what I'm trying to get at is that you could rewrite this problem as x to the 6 with 6 x's, and they are being multiplied. And the whole thought process is that we could pull one of, think of it this way, is the square root of x squared is just x. Same thing with this, the square root of x squared is just x. And the square root of x squared is just x. And I have 3 of those x's, so my final answer is x cubed. Maybe another way that you could think about it, and I think it's actually the rule that we'll be investigating, might be on the next slide. That's okay. We'll keep going through this. We'll see if it makes sense. Is that when we have the square root of something, I could rewrite this as to the 1/2 power. And you may have learned these rules before, that a power to a power, you multiply the exponents. Well, 6 times 1/2 is to the 3rd power. So I don't really care how you come up with the right answer, but that you need to get that the correct answer is this. Whether you're going to write out 10 x's, 3, 4, 5, 6, 7, 8, 9, 10, and pair them together to see how many pairs you have, or if you do what I mentioned right there, that you take x to the 10th power to the 1/2, and a power to a power you multiply. 10 times 1/2 is 5. So I'm going to quickly go through some of these, and you let me know. Either write it down with a question, or maybe I'll make a mistake. But those first 4 are even powers. So what happens if we get into an odd situation? So let me use blue here. So we have 5 x's. Well, just like before, we can bring pairs in front. So it's x times x. But this thing did not have a pair, so it stays under the radical. So we leave it as x squared root x. And you can work through the next one the same way. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many pairs could I pull in front? I could pull in front 4 of them, but I have 1 more left over. So that's what you're going to see me do on the next couple. That I could pull 5 pairs in front, like to the 10th power, but there's 1 left over. And the same thing goes with the next one. So I could pull 12 pairs in front, and then there's 1 left over. And I can do the next one very similarly, okay, except now we're putting in the numbers as well. So let me break down the numbers, 4 and 2, 2 and 2. So just like before with the pairs, I can pull the pair in front, but the 2 stays under this 2 stays under the radical. You're also going to see me have x to the 4th with an x left over, and then y to the 5th with a y left over. So again, I'm probably going to go through those pretty quickly. If I were to break down 32 as 16 and 2, 4 and 4, once you find a pair, that's good. And if you follow the rules, you have x cubed, y to the 4th, and then there's a square root of 2. Don't forget about those. And just go back to them. So I can do the same thing with the next one. We have 49 and 2, 7 and 7, pair of 7s, but we have that root 2 left over. Pair of 7s, root 2 was left over. We have x to the 5th, y squared with a y left over. Now, I wouldn't be surprised if I've made a mistake. So if you find a mistake or if something just doesn't seem right, it might be a reason for it. Same thing with the next one. I want you to practice 9 and 2, 3 and 3, and what you'll notice as I bring out an x and y squared, and my leftovers are a 2 and an x. But we're not quite done, because if I broke down 9 the same way, let's see, 9 and 8, except there's a better number because that's 3 and 3, 2 and 4, 2 and 2. We actually have 2 pairs. So it would have been better if I just wrote down 6, because 3 times 2 is 6. If I have that leftover 2, oh, I have another x with an x left over, and y squared. Well, now we have the like radicals that I can combine together. So this is really 3 of all that plus 6 of all that. So that's 9 of all that. And same thing with the next one. We can simplify this. Let me change colors just to show it's a different problem. 4 and 3, 2 and 2, pairs go in front, and you have to multiply by what else is in front, 4. Maybe it helps you to write out all 3 x's, to bring a pair in front to multiply with that x, so it's x squared. I had 5 y's, so I'd have 2 pairs to bring in front to multiply with that y, and my leftovers is a 3, an x, and a y. Yeah, so if I look at the next one, there's actually nothing to do with the 3, the x, and there will be a y left over because there's 3 pairs that I can bring in front. And here's another piece for you, is it's 4 of all that minus 1 of all that. As long as everything is identical, you can go ahead and do the subtract the coefficients. That's what I did over here. 3 plus 6 was 9. 4 minus 1, and everything else stays the same. We call that algebra manipulation. Just one more, probably equally as difficult as everything else. And I'm going to try and squeeze it in. 7x, that's y cubed, that we could add 5 more y's to, so it becomes y to the 8th, square root of 5. We took out those x's, we took out those y's. So I don't really like how big I wrote that, so let me erase a little bit. And then here I could break out 45 as 9 times 5, and 9 breaks down as 3. I have an x, y to the 7th, to match up with that y, so it's y to the 8th, square root of y. Oh, we got it again. The 7 and the 3 can be added together because all of the rest of the pieces are identical. If you've never done anything like this, you might be in for a treat for the homework because you're going to be practicing a lot of it. The next one's doing a lot of the same stuff. I don't know if you would break it down the same way I would. 50 is 5 times 10, and 10 is 5 times 2, so I have a pair of 5s to pull in front. Definitely have a root of 2. If I count out all 16 of those x's, I'm not going to do that, but you're going to have 8 pairs of them, and same thing with the y's. If you wrote out all 9 of those y's, we have 1, 2, 3, 4 pairs of them, but you had 1 y left over, so 5x to the 8th, y to the 4th, square root of 2y. I think that's perfect. Option 1. But we can also do all of these tricks with cube roots, 4th roots, 5th roots, on and on and on. The thing is, okay, so this is called the index. That tells you what group you want to find. So if I broke down 8 just the same way I did groups of square roots, this time I'm looking for groups of 3. And if you have 3 of something, that's the pair, or I guess in this case the triplet of what I want in front. So the cube root of 8 equals 2. If you don't believe me, your calculator does do this. If you hit the math key, now the x root, you actually just have to type it in. Cube root of 8 tells you the right answer. So I could do the same thing with 125, meant to do this in this color though, of 25 times 5, and break down 5 as 5 and 5. I still have a group of 3, so that's my answer. Same thing goes with the next one, 9 and 9, but look at the index. I want 4 now, so that's why the 4th root of 81 is 3. And you can double check. Math, go to the 5th option, the fourth root of 81 equals 3. And then the other one is the fifth root of 7776. You could do the problem the same way. Apparently comes out to exactly 6. And you, like I said, you could do the problem the same way of breaking it down, and you would eventually see that you have 5 sixes. Excuse me, there's 5 because it's an index of 5. So it's very helpful to know all of these. For instance, you're going to hear me say 2 cubed is 8 without even thinking about it. But the reason why is because 2 times 2 times 2. Well, if I add one more 2 to that, it's going to be 16. If I add one more 2 to that, that's going to be 32. So being able to recognize these without your calculator will be helpful. For instance, I already know without doing the math that that's 27. This is 81. And if you're stuck, yes, you can use a calculator, just to double check that 3 to the 5th power is in fact 243. So you'll notice that I start to trail off after a while. Like I know 4 cubed is 64. I don't know how many other people just know that off the top of their head. But this is where I would trail off because I wouldn't think much about, looking at the wrong one, there we go, 4 to the 4th power. And while I'm at it, 4 to the 5th power. So 256 and 1024. And again, you're probably going to hear me know a few of these, like 125, 625, but then I'm going to trail off for the next one. It'd be cool if you knew it, but you do have access to the calculator on some of these more difficult problems, 3125. But having these in your back pocket, easily accessible, might help you get these other answers pretty quickly. So if I asked you for the cube root of 16, you start breaking down 4 times 4, 2 times 2, 2 times 2. Now remember, we're looking for groups of 2, and we want 3 of them, so that goes in front, and then it's still the cube root of the thing that was left over. So let me circle in a different color that that's the answer I actually want. And you don't even have to be that good at arithmetic to notice, like, hey, I can do 2 times 54. Okay, well, I can do 2 times 27. Well, we can't divide by 2 anymore. So at this point, it might be beneficial to know that 3 times 3 times 3 is 27. Well, there's your group of 3, because it's the index there. So my final answer is 3 in front, cube root, and 2 times 2 is 4. Same thing with the next one. Like on the top of I'm just thinking about 125, I know quickly that that's 5 times 5 times 5. So there's my group of 3 that I write in front, and the index stays the same, and the thing I didn't write under the index, that didn't have a group, stays in there. Same thing with the next one. I'm thinking about 2 and 64. That's 4 times 4 times 4. It's just a time saver that you could pull a 4 in front. Still the cube root of 2. Now, I also need to explain the with exponents, or with variables. Kind of ran out of space. But I have 8 x's. So there's 2 groups of 3. So I can put those together in front and make it x squared. And then the 2 that didn't have a group stay under the radical. And I go ahead and rewrite it that way. So I'm kind of running out of time here, so I'm going to maybe jump to more of these difficult ones of thinking about 64 as 3 4s, and then 2, 2, 2, 2, 2, and 2. Well, I'm looking for groups of 5. So I have one group of 5 with the 5th root of 2 still, and same thing with the x's. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12. So I have 2 groups of 5 to write in front with 2 left over. And then y There's three groups